Hello and welcome back to the video lectures on replacement models. So in this video, we're going to start with the first model, which is replacement of items that deteriorate with time and maintenance cost increases with time. So this is model 1 case 1, and in this particular case of model 1, we're going to ignore the changes in value of money with time. Okay. So this is the same equation from the PDF that I uploaded in April, which tells us when to replace uh, the machine when we are dealing with the case 1 of model 1, when we are ignoring the time value of money. So before that, this is the notation that we are going to use for this particular model. So capital C represents the capital cost of item, capital S represents the scrap value of item, capital D represents average annual total cost, small n number of years, and f of t is the maintenance cost of year t. Okay, so maybe we will be given a data like this where we have f of t, the maintenance cost as a function of time, and for example, uh, t is in years. So the maintenance cost for every year is given. So we may have a given data in the form of table like that. Okay, so during first year, what is the maintenance cost? During second year, what is the maintenance cost required? And finally, at the end or during the nth year, what is the maintenance cost required? And naturally, the maintenance cost will go on increasing. Okay, so based upon this data, we have to use this condition to determine when the machine is going to be replaced. So what this uh, equation says, that if the maintenance cost of next year, so if t is 2, then t plus 1 is 3, that means f of 3 is greater than the average annual cost. So as we are dividing this square bracket by n, we are taking average of that term inside this square bracket. So C is the capital cost, capital S is the scrap value, and we need to add all the maintenance costs. So it's the summation from t equal to 0 to uh, some number of years n, and we are going to sum these maintenance cost up to that certain n, and then finally we calculate the average up to those many years, and then what we get is the average annual total cost. Okay, so if this average annual total cost is less than the maintenance cost of the next year, then we replace the machine. Okay, or I should say opposite. If the maintenance cost of the next year is going to be greater than the average annual total cost up to the current year, then we replace the machine. Okay, so this is the replacement policy for this particular case of model 1. So let me clean this. Okay, so this is what is written here. You can just go through it. And if this condition is not satisfied, then we are not going to replace the machine. Okay, so this is simple, and you will understand the meaning of this equation when you solve the example. So let us solve an example based on this case of model 1. A firm is thinking of replacing a particular machine whose cost price is 12,200. So this is the price at which the machine was purchased. This is capital C. The scrap value of the machine is 200. So if now the company or the firm thinks of selling the machine, then it will go at a value of 200 rupees, which is very small, and as compared to the C. So this is the scrap value S. The maintenance cost for this machine is given here in the table for every year. So during first year, the machine requires a maintenance that costs up to rupees 220. Then in the second year, the machine requires a maintenance which costs around rupees 500, and so on up to the 8th year. Okay, so as you can see that the maintenance costs go on increasing every year. And then this firm is considering this question that when it should replace this machine. So this is the given data, the capital cost of the machine and the scrap value of the machine, and then we have the maintenance cost every year. So let us solve this example using the equation or the replacement policy that we saw in one of the earlier slides. So we are going to do calculations on this line with the help of this GeoGebra spreadsheet, and I have already put the formula or the condition that we are going to test to conclude when the firm should replace the machine. And I have also put the data regarding maintenance cost required for each year at the top. So how we are going to find out when the firm will replace the machine? For that, let us consider this inequality. Now, if let's say that n is equals to 3, then the left hand side of the inequality becomes n plus 1. So F4 is the maintenance cost during fourth year, which is 1200 from the data. And then the right hand side becomes the average of the maintenance cost required at the end of first 3 years, because n equals to 3, so we are going to take the average of the annual maintenance cost of the first 3 years, which we are going to do in the square bracket. So if it turns out that the maintenance cost of fourth year is greater than the annual average maintenance cost calculated up to first 3 years, then we conclude that the firm should replace the machine at the end of third year. Okay, so that's how we are going to proceed. So let us begin the calculations. And before that, let me give you an idea about what values I have put there in the spreadsheet. In column A, this simply is year number. Column B, capital cost of the machine, which remains same, 12,200. Scrap value of the machine is 200, which again remains same. And then column D, I'm going to put the maintenance costs every year. So during first year, the maintenance cost is 220. During second year, the maintenance cost is 500. Third year, 800, and so on up to eighth year is 4,000. Then column E, we are going to calculate the cumulative maintenance costs. So for first year, it's 220 as it is. For second year, 220 plus 500. So addition of maintenance cost for first 2 years. So 220 plus 500 is 720. Cumulative cost after third year, 720 plus 800. So 1520 and so on. Then this is in column F, we are going to calculate the quantity inside the square bracket on the right hand side of the inequality. C minus S plus summation of F of T. So this will be 1220. You can also calculate along with me. You should pause the video and complete your calculations. Minus 220 plus 220. So in column G, we are going to calculate the average maintenance cost. So this comes out to be 12,200 divided by number of years n, or this is the quantity inside the square bracket multiplied by 1 by n as on the right hand side of the inequality. So n is 1 here, that's why this comes out to be 12,200. Then similarly, during second year, we have C is same, so 12,200 minus scrap value is 220 plus the cumulative maintenance cost till second year, 720. So this quantity divided by 2. So that's how you go on doing the calculations here. You can just pause the video and do the calculations. The completed table is on the next slide. So this is the completed table here. You can just pause the video and complete all your calculations. And please verify that you get the same values as mentioned on this slide. Okay? So let us find out during which year this inequality becomes true. Okay? So for the left hand side, which is the maintenance cost in the next year, which we are going to see in column D, and the right hand side is given in column G. Okay. So let us start comparing from the second year, because if n is 1, then f of n plus 1 will be equal to 2. So 12,220 is the average annual maintenance cost at the end of first year, and then we should compare this with the maintenance cost in the next year, n plus 1, f of n plus 1 is 500, so f of 2 is 500. Then we ask question whether 500 is greater than equals to 12,220. No, and hence the inequality is not true for n equals to 1. Then n equals to 2. This is the annual average maintenance cost for n equals to 2. This is n equals to 1. Then we should compare this with the maintenance cost during n plus 1 third year. So f of 3 is 800. Again, this inequality is not satisfied. And if we continue to check, we find that the inequality is satisfied at the end of sixth year. Okay? So as you can see that this is n equals to 6. The annual average maintenance cost at the end of sixth year is 3,170. And then we compare this with f of n plus 1, or maintenance cost during 7th year is 3,200, and now the inequality is satisfied for n equals to 6, and hence the firm should replace the machine at the end of 6th year. So that's the solution of this example. So this is the solution. This is the answer to the question. The firm should replace the machine after 6th year. Okay, so I hope that you have understood how the calculations work in this case of the first model. I will soon be adding the assignments based upon this model. So keep on visiting the section on replacement models. In the next video, we are going to consider second case of model 1. So see you in the next video.